In this session, we are trying to discuss about the example of the mutual information that we have already covered in our last lecture. So, when we try to solve some example, then you will better understand more about the calculation of the mutual information. In example 1, it is saying that the probability of message 1 is equals to 1 by 4, and the probability of message 2 is P2 is equals to 3 by 4, and you need to calculate the information of each message. So I is equal to log 2 1 by p. So if you use the value of p, which is p1 is equals to 1 by 4. So 1 by 1 by 4. So this 4 will be going upstairs because it's a third denominator. So then log 2 of 4, that is equals to log 2 of 2 raised to power 2. So which is equal to 2 bit. Part B is IB log 2 1 by 3 by 4, that is equals to log 2 4 by 3. So you can like convert in this format log 4 by 3 divide by log 2, which is equals to 0.415 bit. Like if you calculate using your calculator, the answer is that. A card is selected at a random from a deck of playing card if you have been told that it is red in color. So you need to determine how much information you received. Second part, how much more information you need to completely specify the card. So what information is given? That a card is given from a playing card and it is said that the color is red. So we already know about the playing card deck that it contains total 52 cards and we have two colors. One is the black, the other one is red. So if you divide 52 uh, 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 by 26, then the answer is 1 by 2 because the total red card is equal to 26. So the probability of red card chosen will be equal to 26 divided by total card, that is 52. So it will be equal to 1 by 2. So half of the probability, if we, because they are likely cards. So we can easily calculate the information by using this probability of the red card, like how much information you received, so that you can easily calculate that information using that formula. I is equals to log 2 1 by p. So we already calculated what is p, that is 1 by 2. So 1 by 2 by 2. The third denominator, it will go upstairs to log 2 of 2, that is equals to 1 bit. The second question was that how much more information you need to completely specify the card. So already 26 selected, like you have already selected one card from the 26 card, and so it means that the probability of that one card will be equals to 1 divided by 26. And then so it means that you can easily calculate the information using this probability. I is equals to log 2 1 by p is equals to log 2 1 by 26. So using your calculator, or you can convert this into that simple formula log 26 divided by log 2, and then using your calculator you can see that the information will be equal to 4.7 bits. Let's do another example so that we can better understand. Consider a memoryless source C that outputs 2 bit at a time. So this source comprises two binary sources A and B, whose outputs are equally likely to occur and each contributing 1 bit. Suppose that the sources within the source C are independent. What is the information content at each output from source C? So source C is outputting two at a time. Sources like C is A and then the other one is B. And each source is contributing by 1 bit. So it means that it can be equals to 0 or it can be equals to 1. Similarly, for B, it can be equals to 0 and it can be equals to 1. Total sample of C that belongs to 0 0 0 1 and then 1 0 and then 1 1. So that is the combination. So four samples. So the total probability of PC is equals to 1 by 4. Or you can say that the probability of A, that is 1 by 2, because equally likely they can either mm, uh, contribute 0 or contribute 1. So you have two bits, so that is why the probability of A is 1 by 2. Similarly, B is also contributing by 1 bit 0 or 1, so the probability of B is also can be equals to 1 half. And we have already known that they are independent. If they are independent, then the combined probability is the product of the probability of A and B. So that is product of 1 by 2 multiplied by 1 by 2, that is equals to 1 by 4. So that is the combined probability. So using this probability, we can calculate what is the information of C. So log 2 1 by PC. So that is equals to log 2 1 by 4. So the 4 will be upstairs, and we already know that the log 2 of 4 will be equals to 2 bit. So that is the probability. So we have already conclude that if the sources are independent, then their information will be added, and we can even calculate the source entropy, that is the average information per symbol. And so it means that the information basically equals to the probability multiplied by the log 2 1 by probability. So this is basically the average information per symbol. So, like if you want to calculate the entropy of a source, so you can use this example. So, entropy can be defined as a measure of average information content per symbol. So, H is equal to sum of P log 2P. So, tossing a dice, so outcome can be equals to 1, 2, 3, 4, 5, or 6. Each occur at a probability 1 by 6 because total are 6 outcomes. Information provided by tossing a dice. So that is, if you are like summing up all them from 1 to 6, probability of I log 2 probability of I. So that means that the probability of I, that is equals to 1 by 6. Probability of every outcome is equals to 1 by 6, but the outcomes are different, like 1 by 1, and then log 2 1 by 6 plus log 3 1 by 6 plus log 4 1 by 6, because the probability of each event is 1 by 6. So that is why probability will be 1 by 6 6 times. So if you are adding them 6 times, the answer will be log 2 of 6, that is equals to 2.58 bits. You can even represent the probability using this formula as well. So, like using that formula, you can even calculate the speed of a source, that is equals to the entropy divided by the time. So, where t is the duration of a symbol in a message. So, I hope that you understand uh, all the examples and questions. But if you still have any questions, you are most welcome. You can write your question in the comment box, and we are giving you these examples to solve. So we are leaving this example for you to solve this example and write your answers in the comment box, so that we will see if your answers are correct or not. So thank you for watching the video.